Welcome students. In this video, we discuss about proper rotation axis and its symmetry operations. What is proper rotation axis of symmetry? The rotation of a molecule about an axis through some angle results in a configuration which is indistinguishable from the original structure. Then the molecule is said to possess proper rotation axis of symmetry. It is denoted by the symbol Cn. C refers cyclic. N is equal to 360 divided by theta, where theta is the angle through which the molecule is rotated. Cn is called n-fold axis of symmetry. N is the order of the axis. Let us consider an example. Water molecule. Water molecule is rotated through 180 degree about the axis, passing through the oxygen atom and bisect hydrogen, oxygen, hydrogen bond angle to get an indistinguishable structure. During the rotation, the positions of the hydrogen atoms are changed. We get an indistinguishable structure. For the symmetry axis, n is equal to 2, that is 360 divided by 180. This is called two-fold axis of symmetry. It is denoted as C2. Similarly, if the angle of rotation is 120 degree, then n will become equal to 3, then it is denoted as C3. If the angle of rotation is 90 degree, then n will become equal to will become equal to 4, then it is denoted as C4. Identifying proper rotational axis. Consider an example of boron trifluoride. In the boron trifluoride, it has a planar triangular structure. All the atoms, that is the boron atom and the 3 fluorine atoms, are in the same plane, that is molecular plane. In the boron trifluoride, there is one C3 axis. That axis passes through the boron atom and perpendicular to the plane of the molecule. During rotation, we get an indistinguishable structure. Similarly, the boron trifluoride also contains C2 axis. That is 3 number of C2 axis. Each C2 axis passes through boron atom and one of the 3 fluorine atoms. The 3 C2 axes are in the molecular plane. During the rotation, we get indistinguishable structure. Thus, boron trifluoride contains 2 proper rotation axes. One is C3, another one is C2. Symmetry operations are associated with the proper rotational axis. Similarly, in this symmetry operation also, we consider an example of boron trifluoride. When boron trifluoride is rotated through 120 degree, passing through an axis through boron atom perpendicular to the plane of the molecule, the positions of the fluorine atoms are changed. The F1 atom occupies the position of F2, F2 atom occupies the position of F3, F3 atom occupies the position of F1. It is denoted as C3 or C3 power 1. On further rotation about 120 degree, the positions of the fluorine atoms changed. This operation is denoted as C3 power 2. On further rotation about 120 degree, the positions of the fluorine atoms changed and it is denoted as C3 power 3. During this operation, we get a structure that is identical to the original structure. Therefore, the C3 power 3 is also written as E. On further rotation, about 120 degree through the same axis, the operation is denoted as C3 power 4, which is we get a similar structure what we get during the C3 operation. Thus, the operations generated by C3 axis are C3 power 2 and E. For further information, visit my blog. Thank you for watching.